Pleasure being here Friday afternoon. I know it's kind of the last session of the month, but thank you to the audience. My name is Tanmay Aggarwal. As Jake mentioned, founder and CEO at Lambda Function. We are a startup out of San Francisco, started in 2020, working on the problem of how do you go from a CAD model to machine part with minimal to no human intervention. Today we partner with companies like Siemens, Autodesk, Mastercam. Mastercam is here as well. And on the machine tool building side, work with companies like DMG Mori and several others. So with that, again grateful for SME to invite me here for this presentation. Since the last 4 or 5 years, we've had an opportunity to be pretty much at the forefront of where AI/ML is being used for the use case of precision manufacturing. And through that, we've learned some good, bad, and ugly of what it means. And when I was talking to SME, we figured that could be an interesting topic for today's conversation. So with that, we're going to get started. We're going to start by talking about Mars and cars, rockets and watches, and rockets and microscopes. Is that better? Okay, perfect. So we said that we'll start by talking about some of these industries. And the reason I say that is because all of this, as we know, exists because of parts manufacturing and precision machining. So from a topic of why we do what we do, we see this being highly relevant to global supply chains, agnostic of be it consumer electronics, to automotive, to aerospace, to defense, space, and what have you. Now, in this domain, why are we talking about it today? We see the world of advanced manufacturing is under a lot of pressure. If you think about what's happening here in North America, there's pressure to do reshoring and onshoring. There's massive increase in complexity as you get into more customization and precision. And as we all know, there's massive workforce gaps. So how do we think about scaling machining capacity without scaling risk? And so that problem, we talk about where we see the real bottlenecks today. From our lens, the problem is not that we don't have simulation capabilities like what CAD gives you. We have really amazing CNC machines that have been built up over the last 40, 50, 60 years. But the challenge is all the decisions that are still reliant on the human expert in that workflow. And as we have fewer and fewer experts entering this workforce, you start asking the question, if you forecast 5, 10, 15 years out, how will this industry continue to make all the amazing parts that we take for granted? We see the problem basically being a gap between the design world and the manufacturing world. The design world is kind of where all the CAD modeling is happening. The manufacturing world is how you turn those beautiful designs into actual reality. So decisions like, how will I go about machining that component? Which cutting tools should I use? What parameters should I be using, like feed speeds and whatnot? And how do I reduce the iteration cycles that currently the industry's gotten used to? So if you think about the need to bring new products to market faster, we're sitting at CES. Of course, we've got into this idea that consumers are expecting more personalized, better products faster. How do you bring that entire life cycle down? It's kind of why we believe we're having this conversation. Now, why has historical attempts at automation failed? And that's kind of get us into the world of why AI/ML might be relevant. When we think about automation, this topic of trying to bring more automation to this work in this entire value chain has, of course, existed for a long time. People from the 80s and the 90s have spent a lot of time trying to do automation. Things like feature-based machining, for the folks who are closer to the subject matter, probably can understand that as well. But historically, this has all been rule-based templates, static experience-based feeds and speeds, best practices that are really just trapped in the individuals who've gained that experience over the years, and finally, limited learning from one job to the next. All those challenges have continued to create a world reality where if you want to go from a CAD model to a machine part today, let's say in the aerospace domain, it can take you easily maybe 40 to 80 hours of time to just do that upfront CNC programming that's needed to make that component. It might take you another 8 to 12 iterations to prove that upfront program down to the point where you can actually do at-scale production. All of that is where the real problems and costs lie. So when you think about what do we mean by AI in this domain, from the 4 or 5 years of us going really knee deep into this subject matter, we're not talking about full autonomous CNC machines today. We're not talking about one-click programs that you click a button, black box AI is going to do the work. What we are starting to see some very tangible, pragmatic outcomes on is we're starting to see that we can learn from these rules-based systems and train algorithms that can thereby turn the static learning into more dynamic systems that can learn over time. We are starting to see optimization algorithms that are good enough to do multi-objective optimization that the human beings historically have had to rely on just trial and error experience from. And we're also starting to see the mechanism where we can learn from outcomes, so creating a true feedback loop from what's happening so that the learning and the knowledge gets captured over time. Those are the realities that we're seeing today. So now where AI fits into the machining lifecycle, we're seeing that this is starting to augment 4 stages of the lifecycle. We are seeing very pragmatic use cases emerge from various companies in the world right now on AI-assisted CNC programming. Think of it as like a low-code, no-code solution for CNC programming, for G-code generation. Second, all the decisions related to CNC programming and how do you get to that perfect CNC machine part, like tooling and parameter, we're seeing a lot of applications where we can actually bring the physics and mathematics of material removal to the human expert where they're doing their job so that they have less reliance on just their experience over time. Another area is machine execution behavior. Today, the challenge we see in the world of precision manufacturing is that you have a static code file that's been built in the world of CAM, which expects something is nominal, that's simulated, that's theoretical, and you put that on a dynamic system. So that's a huge opportunity where AI is starting to play a role in creating that feedback learning system. So where we see thereby kind of what's the business value that's starting to get unlocked in the value chains all the way from OEMs as well as tier 1 and tier 2 manufacturers, honestly agnostic of geography, is we're seeing significant meaningful gains when it comes to cycle time reduction, be it automotive. We're seeing significant improvements in first-time yield, so reducing the time it takes to get to that prove-out and get to production faster with more complex parts. We are seeing more knowledge capture and consistency happen, so that if you have experts in your company and you want to capture that knowledge and port it over to other parts of your company, which may not be sitting right next to that expert, you can start doing that in a more dynamic manner. And finally, a significant ramp up in training the younger skilled workforce. As they go up the learning curve, historically it can take you 6 to 8 years to become an expert CNC programmer. With what's happening with AI in the world of CNC programming, we're bringing that time horizon down to months, which is a massive reduction in terms of time. Where AI is not yet ready is we are definitely not at the stage where we can say, hey, we can have an AI layer that's going to get you to full lights out machining. We are starting to see some light out factories in the world, of course, been talked a lot about by folks like Siemens, they're the leaders in space and several others, who are starting to demonstrate what that arc of the future, what that arc of the possible could look like. But for the majority of the world, we're not at the point where we can talk about lights out machining. We're definitely not at the point where in the world of precision manufacturing, where we're talking about, ultra precise components which are functionally mission critical. We're not at the point where we can say that we need zero human validation. Of course, if you have challenges in other parts of the value chain, be it poor fixturing, poor designs, upstream in engineering, we're not at the point where that's going to get solved just through one universal, one model. So we're starting to see more specialized models starting to come in that can tackle different parts of the value chain. That gets us to what are we seeing as kind of pragmatic pathways today for companies to start looking at adopting AI in the domain we're talking about. So we see 2 specific pathways emerge, one being the CAM side and the other side being the shop floor, the machining intents. So both of those allow pathways for organizations to come in. In the real world, what we're seeing right now, for example, if you're in an automotive company, you deal with high volume production, you care a lot more about what's happening in your shop floor. And if you can squeeze out even seconds out of your cycle time, that's going to drive massive gains. We're seeing significant low-hanging fruit, 15 to 20% reduction in cycle time because you're able to track data at that high fidelity. Upstream, for dealing in more complex CNC environments, which are high-mix, low-volume environments, be it aerospace, defense, space, semiconductor equipment manufacturing, in those domains, the CAM side becomes an important part because it's a huge bottleneck today. We hear it often and often again. We have a lot of demand, so we're talking to manufacturers. They're seeing a lot of demand to make parts. They just don't have enough people who can generate the programs that are needed to make those components faster. So we're seeing massive gains come through. Now, of course, we believe that the highest value comes when you start connecting the two, because now you're starting to get closer and closer to create a more real-world digital twin of the vision that companies like Siemens are talking about, be it the digital twin that's a factory for the future. So two deployment patterns, and I'm going to go a little bit deeper into that, AI and CAM workflows. So what we're seeing is companies are starting to develop native AI capabilities into existing environments of CAM. So you're meeting the user where they live. You're trying to minimize change from a behavior pattern perspective, and you're training algorithms that understand material removal physics, that understand the concepts of the subject matter in order to be an AI assistant to the user. Again, I look at it as a low-code, no-code tool. Over time, as the technology starts earning the trust of the user, you can start relinquishing more and more control to the technology to generate more autonomous workflows. But today, that AI-assisted workflow is becoming very real, and active deployments are happening across supply chains, across geography at this point. The second workflow, like I said, is from the machining side. Now, over the last 10, 15 years in this industry, we've seen that machine connectivity has become a topic that people are starting to talk about and accept. More and more shop floors are getting connected to IT systems. So the IT-OT convergence is happening. Because of that convergence, now we can unlock additional use cases, which can start unlocking customers to get closer to the lights out operations that they're looking for. So specific decisions like when should I change a cutting tool? I always like that example. It's like a very simple question. How do you know when to change your cutting tool in a machining shop environment? And most often than not, you'll hear it's a non-data driven decision. It's based on the experience of the operator. Now you can turn that into much more AI assisted decisions, which gets you closer and closer to the lights out. Now, of course, you can't do that without robotics. So some of the conversations we've had earlier today become very relevant. Then you kind of get to the point where when you start thinking about more high complex environments where the customers are already much more sophisticated, they are starting to look at, well, how can I close the loop? Because elements of this have existed, and again, companies in their adoption curve have gone down adopting parts of this puzzle, but where they're seeing the value really get unlocked because of what's happening in the field of AI is when you start connecting those dots together. A lot of our conversations in this with some of the largest OEMs in the space come from the lens of model-based engineering and digital thread enablement. If you think about, we were talking about the DoD earlier and the mandates of characteristic traceability, you're almost reaching a stage where some of the largest enterprises are now mandated to have certain degrees of traceability across the entire part life cycle. And today the breakdowns tend to happen when you go from CAD to CAM, CAM to metrology. Each step of that puzzle creates a silo today. And that's where the closed loop architectures are really able to start unlocking those value opportunities. This is a short case study. We did this in partnership with Siemens actually at their site in Chicago. It was a great way to showcase how the closed loop capability within the Siemens ecosystem, if you think about their CAD/CAM ecosystem, up front from the Unigraphics and from the NX side, and then downstream on the motions control side with the cinematic controllers, how do you bring all that together to unlock value? The biggest thing that we saw in this case study, which I found most fascinating, was the significant gap between the simulated assumptions that we were making up front in the world of CAM programming versus what actually happened when you track the data in real time on the shop floor. And that delta deviation is what allowed us to reduce the iteration cycles to get to prove out cycles faster. How is impact really getting measured today? Again, we talked about cycle time, we talked about first pass yield, tool life stability, and programming learning. These are tangible areas where we're able to start delivering value, where the customer can actually start making money because of that. Honestly, that's what I love about this space, because I think, going back to, it's not about the hype, it's about what can be pragmatic, what can be trustworthy, what can be reliable, and I think that creates a way to bring technology to the domain of industrials in a structured manner. Now, from a workforce standpoint, I think this has been talked about a lot. AI is definitely starting to become a workforce multiplier in this domain as well, because you're seeing expert CNC programmers who are seeing the benefit of leveraging AI tools to port their knowledge to the junior folks so that their time can be spent on higher value activities. So we see significant benefits there. And again, another area from a workforce education lens is how do you attract younger people to enter the domain of precision manufacturing? And we find when you start bringing in conversations about how AI is being used in the world of CNC, people get excited about the world of CNC. And that creates a multiplication effect. Now, of course, again, these are probably things that folks have talked about in other sessions, but it's not easy. I was talking to somebody earlier at JR. It's not a widget. It's not yet at a point. The technology is not mature enough. Customers' environments are not mature enough where we can just go in and plug and play. There are certain best practices that have to be in place that thereby straddle the adoption curve. And that adoption curve is kind of what we're starting to see emerge in the market. What needs to happen to start integrating some of this capability in the workflow? We are seeing, for now at least, in the absence of more advanced simulation engines, CAM native workflows play a big role. Incremental deployments, crawl, walk, run, earning the trust again of the technology. The technology needs to earn the trust of the user. We constantly feel that's the way to start getting to enterprise deployments. And how do you minimize operator change, behavior change? Again, behavior change being one of the most difficult things to deal with in this scenario. Where do we see common pitfalls? Again, this goes by the stage of the company. OEMs maybe have different challenges than tier ones or tier twos, but trying to do too much at the same time, expecting that AI will just fix your processes, is often not a great starting point. Change management is some of the things that probably today are the biggest learnings, as the technology often is not the blocker, as we know at CES. And treating AI as being an IT-only problem, given the world we live in, requires to straddle IT and OT. From a security and IP consideration, a very, very important topic. People are, of course, for good reasons, concerned about how that data is going to get used. So by default, data privacy and private models becomes a starting point. And again, we're going to see different flavors, different companies will go after the problem statement in different ways, depending on the segment of the market they're going after. If you're dealing with enterprise customers, you're dealing with some of the largest companies with complex domains, data privacy would come first. So data ownership has to lie with the customer. Model isolation. Customers need to have private models that are only for their own need. Having flexibility in deployment options is incredibly important. You cannot expect a customer may want to put all of their OT equipment in the cloud. So having that flexibility becomes important, and traceability and auditability. Be it from a compliance lens or from an internal traceability lens. Going back to business value. So today, this is where we see tangible ROI coming from, and in this relative ways. We see productivity enhancement, it's a no-brainer, cycle time improvement, tool spend reduction, rework and scrap reduction. So again, very tangible ways that can deliver ROI on new technology adoption, which we think is incredibly important. The most important, which I think is really valuable, is with AI deployments, you actually do get the benefit of compounding advantage. So for the companies that are able to start earlier, they just are much more ahead of everybody else because of that compounding impact that gets created with AI. And I think that creates a very strong lever. When we think about a realistic AI roadmap, this is just an example blueprint. Again, we look at it from the lens of how easy is it to get started, what's the risk, what's the business impact it can deliver. We're starting to see top to down AI-assisted CAM, relatively easy. You can literally today have a free version in the cloud that you can just download on your app, on your environment, and get started. And that we're seeing is creating a huge momentum all the way for the citizen developers, quote unquote, and the large companies who don't want to yet go through the whole red tape process to get started with something, or alternatively to the small and medium-sized enterprises who do not have the capacity to take on very big deployment projects. So AI-assisted CAM becomes quite easy to get started. AI-assisted shop floor becomes slightly more involved because now you're getting into the IT/OT layer, and finally closed loop starts coming to the more digitally mature organizations. Where we see this headed, and the two cents that we have, is today we're at the point AI environments in CAM and machining. We are getting closer and closer to more integrated manufacturing agents, finally getting to the point where we can have an AI control layer. This is kind of, potentially a few years away, but we're reaching that stage where this workflow can start unlocking autonomy in a much more predictable and a reliable manner. This is not going to happen alone, so a lot of industry players and partners are starting to come together to think about what role do they need to play in the value chain that they bring to the table. So last slide for today. We see AI right now being most efficient in decision bottlenecks. We do believe early gains are compounding over time. And again, I think education and awareness is very important. It's equally important as the advancements of the algorithms. So with that, I'll open it up for questions.